In this video, I'm going to show you how to find a plane's equation in scalar product form, as well as how to use that result to find its equation in Cartesian form. For that, I'm going to use what I wrote here, in which I say that a plane called pi is such that it has a normal n, which is equal to 3i minus j plus 4k, and it contains the point A, whose coordinates are 1, 5, negative 2. And to help us visualize what we're dealing with, I've drawn a generic plane in 3D space here. Looks a bit like a flying pancake. So, we'll start with the scalar product form, and I'll just write that. That's the scalar product form. To write a plane's equation in its scalar product form, we need two things. First of all, we need a normal to the plane, which is the first thing we're given here. Secondly, we need the coordinates of a point contained in the plane. And that's the second thing we're given here. Indeed, we're given the coordinates of this point A. And I can add those two things to my diagram here. So we have a normal n, which I'm drawing here in yellow, as well as the coordinates of a point A contained in the plane. Now, to write a plane's equation in scalar product form, we use the following result. n dot r is equal to n dot a. And I'll go ahead and box that result. Do make a note of this. Looking at this result, or this equation, the vector n that we see on both sides is the normal to the plane, and the vector a is the position vector of the point A. And in fact, I could add that position vector to my diagram here if I draw this vector pointing towards point A, something like this, and I'll label it A, and its components would be given by the coordinates of point A. In other words, vector A is equal to 1, 5, negative 2. The vector r that we have here is the position vector of a generic point that's contained in the plane. In other words, vector r is the vector x, y, z. And I could add that to my diagram. I can just randomly place a point here, and I'll call that capital X, and the vector r would be the position vector pointing towards that point. And I'll just label that r. Now, although this equation or this result is what we'll use, to write a plane's equation in its scalar product form, we'll actually need to calculate the scalar product on the right-hand side here. And in doing so, this turns into n dot r equals to some number, which I'll go ahead and call capital D. And that's the scalar product form of a plane's equation. And in fact, I'll go ahead and write that next to it. I'll say scalar product form. Scalar product form. There we go. So for the plane pi that we have here, let's go ahead and replace the vector n, the vector r, and the vector a by the vectors we've defined here. Well, let's see. As a column vector, the vector n would be 3, negative 1, 4. And so we're calculating the dot product with the vector r, which remember is x, y, z. And that's equal to the dot product of the normal vector, so that's 3, negative 1, 4 again, and the vector a, whose components are right here. That's the vector 1, 5, negative 2. And I'll quickly copy that. That's 1, 5, negative 2. Now, all we need to do to write this in scalar product form is calculate this scalar product or dot product on the right-hand side. And I'll do that up here, so I'll copy the left-hand side. That was 3, negative 1, 4, dot, x, y, z, and that's equal to the dot product, so that's 3 times 1, so that's 3, plus negative 1 times 5, so that turns into negative 5, plus 4 times negative 2, so that becomes minus 8. Now, 3 minus 5 minus 8 equals to negative 10, so the scalar product form of this plane's equation would be 3, negative 1, 4, dot, x, y, z, equals to negative 10. And I'll go ahead and box that result. There we go. And one of the great things about the scalar product form of a plane's equation is how easy it now is to get its Cartesian equation. Indeed, all we have to do is calculate the scalar product that we have on the left-hand side of the equation. And that would be 3 times x, so that's 3x, plus negative 1 times y, which is just minus y, plus 4 times z. And I'll just write that. That's plus 4z. And that's equal to negative 10. And that's the Cartesian equation of this plane. And there we go. We now know how to write a plane's equation in scalar product form and find its Cartesian equation from it using a normal to the plane and the coordinates of a point contained in that plane. And that's it for this tutorial.